Hi, linear algebra students. In this video, I will show you pretty much the only exercise that I made a video on for applications of linear systems. Take note, it's an exercise, meaning that it's certainly in your reach, okay? You should be able to do this thing. It's not difficult at all. Let's just read it together. Find the second degree polynomial passing through this point and this point, okay? And second degree means that you have three terms. So you would actually need a third point in order to be able to interpolate the polynomial through. However, instead of a third point, they give you this weird condition, okay? And that's where I'm expecting most students to be stuck. You will write these two conditions very well, but then this might confuse some of you. So for which the tangent line at x equals 3 has slope 14. So okay, let's actually write what these two parts of the problem mean. So, for example, this one right here, we know that the polynomial is passing through this point. This means that p of 1, remember this is the x coordinate, is equal to -6. Okay? Now, if you were to translate this as an equation, remember of my advice. So write the polynomial in the constant term first, and then the linear term, and then the quadratic term. So in other words, write the terms in increasing order of power. That will make the solving easier. So p of 1 is equal to 6. So a polynomial of degree 2 has this form: a0 plus a1x, in this case x is 1, plus a2x squared is equal to -6. Okay, so this is the first equation. The second equation is given right here, okay? And it's exactly of the same type. So this you have no problem most of the times. So p of 2 is equal to -1, means that this same polynomial, a0 plus a1 times 2 plus a2 times 2 squared is equal to -1. Now, here comes the tricky part, okay? So try to figure it out by yourself, okay? I would actually encourage you to close this YouTube video if you hadn't tried that. It's in your calculus notes, okay? So it's not something that we saw in this course, but you have seen it previously when you were taking calculus, okay? The tangent line at x equals 3 has slope 14. So what you should know is that the slope of the tangent line at x p of x is actually the derivative at that value of x. Let's write that down. So the slope of the tangent line to p of x at, or actually, let's write to p of x, no problem here. At x equals 3 is p prime of 3. There you go. So whatever value you have, that's the value that you replace in the derivative. So what it means is that what this third condition is saying is we want the slope to be 14. In other words, we want the derivative at 3 to be equal to 14. So we want p prime of 3 equal 14. There you go. So obviously at this point, what you simply need to do is to take the derivative of p of x. Okay, so let's write down what p of x is. P of x is a0 plus a1x plus a2x squared. This is seriously one of the easiest functions to differentiate. Okay, remember that, so this differentiates to 0, this differentiates to a1, and there you have plus 2 a2x. Okay, and we'll get the third equation from here. So replacing 3, we know that p prime of 3 must be equal to 14, and this is equal a1 plus 2 a2 times 3. Okay, so now we have all the conditions. Let's write the system of equations, okay? I'll write it over here. So in this little box here, yeah, this will be perfect. The red equation is simply a0 plus a1 plus a2 is equal to -6. The orange equation, a0 plus 2a1 plus 4a2 is equal to -1. And then the third equation that comes from this funky condition is, so 0 here plus a1. So, and actually I'm not going to write anything here, plus 6a2 is equal to 14. Okay, so this is the system of equations that we aim to solve. I want you to realize that this was the most important part of the problem. Afterwards, the only thing we need to do is to solve that system and interpret our solution. So now I'm going to erase everything except the box, and we're going to put this system into a matrix. So where's my eraser? There you go, found it. Sorry about that. So I'll drop the color coding here. 1, 1, 1. And then -6. 1, 2, 4 with -1. And finally 0, 1, 6, 14. Okay, so these are our three equations that we put in the matrix in order to solve it. So, okay, here. This is perfect. We will take this as a pivot, and we will change the second row to, will become row 2 minus row 1. Let's start by just doing that. We have 1, 1, 1, -6. So the first and third row do not change. And the second row become 0, 1, 3, and -1 plus 6 will give us 5. All right. Then after that, as you can see, we will create a pivot over here. So we have a pivot here already. We want a pivot over there. So we will change row 3. That will become row 3 minus row 2. And I will write the matrix right here. So So 1 minus 1, 0, 6 minus 3, 3, and 14 minus 5 will give us 9. All right, perfect. Okay, so we have our pivots. 1, 2, 3. Okay, so here, let's deal with these two already, because this row, as you can see, is a multiple of 3. So let's eliminate directly the 1 and the 3 here. The first row, row 1, will become row 1 minus a third of row 3. And the second row will be, row 3 will become row 3 minus, oh, oops, second row, so row 2 over here will become row 2 minus row 3. There you go. So the matrix will give us. And now at this point, I will erase the system. It will get in the way. So row 1, okay. 1, 1, and then 1 minus 1, 0. And negative 6 minus 3 will give us negative 9. And then here, 0, 1, 3 minus 3, 0. 5 minus 9 is going to give us negative 4. All right, we're almost done. So remember, we have our pivots right here. So we need to eliminate that one. And as you can see, we can also actually scale down this, because this operation, we will do an operation with row 1 and row 2 to eliminate that one. And since row 3 is not involved into that row reduction, we can directly scale it down. So we will do 2 operations at once. Row 1 will become row 1 minus row 2. And we will scale down row 3. Row 3 will be 1/3 of row 3. So let's just copy first row 2. That doesn't change. Okay, so first row, 1, 0, 0, and negative 9 plus 4 will be negative 5. And then here, simple, we just divide both of them by 3, so 1 and 3. All right, this is our solutions, but keep in mind that we're in the context of a polynomial, and what we actually found were the coefficients. Okay, I don't have enough space to write them on the top, so I will write them at the bottom. Remember that the first column was representing, I will write in red, let's say. Yes, the first column was representing A0, second column A1, and third column A2. So in other words, what we found is A0 is equal to negative 5, A1 is equal to negative 4, and A2 is equal to 3. As a conclusion, the polynomial that satisfies all of the 3 conditions, and remember, this is easy to check actually. We will check maybe one of these 3, not all 3, but these are easy to check. And to make sure that you have the good answer, you should actually check all of the conditions to see if that makes sense. Okay, so pretty much what you do is negative 5 minus 4x, because this is A1, okay, plus 3x squared. And this should be your final answer. Actually, let's just try to check them very quickly, okay? If you replace 1, okay, so if you replace x by 1, what do you get? Negative 9 plus 3, negative 6. This is checked. If you replace 2, this involves a little bit more mental math. So you'll get negative 5 minus 8, so negative 13. And this will give you plus 12. So that's it. You get your negative 1. And finally, the derivative, a little bit more tricky. So negative 4 plus 6 times 3. So negative 6 times 3, what does it give you? It gives you 18. 18 minus 4, 14. You're good to go. This is the answer. I hope this helped, and see you in the next video.